Hey there, data enthusiasts! Welcome back to our channel, where we dive deep into the fascinating world of data science and machine learning. If you're new here, don't forget to hit that subscribe button and ring the bell so you never miss an update. Today, we're going to tackle a crucial topic that can make or break your machine learning models: cross-validation. So, let's get started. Have you ever trained a machine learning model and wondered, how do I know if my model is any good? Well, that's where cross-validation comes into play. But what exactly is cross-validation, and why is it so important? Let's break it down. Cross-validation is a statistical method used to estimate the skill of machine learning models. It's a technique that helps us understand how our model will perform on unseen data, which is critical for building robust models. So, how does it work? Let's explore a couple of popular methods of cross-validation: k-fold cross-validation and leave-one-out cross-validation. First, k-fold cross-validation. Imagine you have a dataset with 100 samples. In k-fold cross-validation, you divide this dataset into k equally-sized subsets, or folds. For example, if you choose k to be 5, you would split your data into 5 groups of 20 samples each. Here's the process. 1. You train your model on 4 of the folds and test it on the remaining fold. 2. You take turns doing this, so each fold gets to be the test set once. 3. Finally, you average the performance scores from each test to get a more reliable estimate of how your model performs. This method helps prevent overfitting, which is when a model learns the training data too well, including its noise and outliers, making it less effective on new data. Let's look at an example. Suppose you're working on a model to predict house prices based on various features like size, location, and number of bedrooms. If you use k-fold cross-validation with k set to 5, you'll get 5 different performance metrics that reflect how well your model can generalize. This gives you a better sense of its capabilities than a single train test split. Now, let's move on to leave-one-out cross-validation. This is a special case of k-fold cross-validation where k equals the number of samples in your dataset. So, if you have 100 samples, you will train your model 100 times, each time leaving out 1 sample for testing and using the remaining 99 for training. While LOOCV is thorough and provides an unbiased estimate of model performance, it can be computationally expensive, especially with large datasets. In contrast, k-fold is often preferred for its balance between accuracy and efficiency. But wait, there's more! Cross-validation isn't just limited to these 2 methods. There are other variations, like stratified k-fold, which ensures that each fold has an equal distribution of classes, making it particularly useful for imbalanced datasets. Let's clarify with another example. Imagine you're building a model to classify emails as spam or not spam. If your dataset has 90% non-spam and only 10% spam, using regular k-fold could result in some folds having no spam emails at all. In this case, stratified k-fold would ensure that each fold maintains the same proportion of spam and non-spam emails, giving you a better assessment of your model's performance across different classes. Now, let's talk about evaluation metrics. After performing cross-validation, you will have multiple performance scores. Common metrics include accuracy, precision, recall, and F1 score. Depending on your problem, you may prioritize one metric over others. For instance, in medical diagnoses, you might want to focus more on recall to minimize false negatives, while in email classification, precision might be more critical to avoid marking important emails as spam. In summary, cross-validation is essential for reliable model evaluation. It helps you avoid overfitting, ensures that your model performs well on unseen data, and provides a comprehensive understanding of its effectiveness. Alright, folks. To wrap it up, cross-validation is a powerful technique that allows us to assess the performance of our machine learning models more reliably. Whether you use k-fold, leave-one-out, or stratified k-fold, incorporating cross-validation into your workflow will significantly enhance the robustness of your models. If you found today's video helpful, please give us a thumbs up and share it with your fellow data lovers. Also, let us know in the comments how you use cross-validation in your projects, or if you have any questions about the topic. And remember, practice makes perfect. So don't hesitate to experiment with these techniques in your own projects. Thanks for watching, and we'll see you in the next video.